In this live code video, we'll go through how to find the line of best fit and use it using linear regression. The data we're using is from the Old Faithful geyser in Yellowstone National Park. This geyser has gotten its name because it's a bit faithful with the way it erupts. So Old Faithful erupts every 35 to 120 minutes, and each time it erupts for about 1.5 minutes to 5 minutes. So we're going to take a look at the data and see if the wait time, or the time between eruptions, affects the length of the eruption itself. First, we'll set values for the x and the y. The x is the independent variable, so this will be the wait time. And the y value is the dependent time. We're going to see if the eruption time depends on the wait time. So we'll set y equal to the eruption time. Now, before we do anything, we want to see if there's a correlation. We'll name this correlation, and we'll correlate y in respect to x. And let's print this. It looks like our correlation is 0.9, which is a pretty strong positive correlation. So let's plot this. This code will set the title to Old Faithful eruptions, the x label to the wait time, and the y label to the eruption time. Then we'll take this data, we'll take the x and the y, and we'll plot a scatter plot. Well, it definitely looks like that there is an increasing pattern between these two variables. So let's create a model. We'll name it model, and we're going to use the NumPy library and the polyfit function. We want to use the x values, the y values, and we want a linear equation. And let's print and see what this gives us. Yep, it looks like I misspelled polyfit. Now let's try again. Great, so down here you'll see two values. They're in a list. The first value is the m, or the slope, and the second value is the b, or the y-intercept. Let's use this information and actually print out the equation we're going to be using. So m is the first element in that list. So we can grab that element by calling on the list and the element with the index of 0. We can do the same to find b. This element has the index of 1. So let's print out the model. The model is y equals mx plus b. But we actually know what m is, so we can add it here, and then continue on with the rest of the equation. We know b as well, so we can add that here. One last thing that we'll have to do is the only way that we can concatenate these values is if we turn them into strings. Let's see what we get. And there's our equation. We can also round it if we'd like, to make it a bit neater. Let's round it to 2 decimal places. Excellent. So our model equation is y equals 0.08x plus negative 1.87. Now let's use this model equation and predict a few values. Also, just as a side note, don't forget to include this plt.show at the bottom. Otherwise, your graph will not show up. Let's name this predict, call on the NumPy library, and this time the function is poly1d. What we want inside of this function is our model. Then we can use this predict to predict certain values. Let's see what would happen if we waited for 60 minutes. So it looks like if we waited 60 minutes for Old Faithful to erupt, the eruption would last about a little longer than 2.5 minutes. Let's see if we waited 90 minutes, an hour and a half. It looks like our eruption time would be a bit longer, almost 5 minutes. Now that we have this model and the predict function, what we can do now is plot the line of best fit. So let's first determine the minimum and maximum values of the x-axis. This would be hard to find in a dataset this big, so we're going to use the minimum and maximum functions. We're checking on the wait time, and we'll print out the minimum and the maximum. Looks like we're going from 43 to 96. So what we'll do is we'll use these values to plot the x-axis on the linear regression. So we'll name that x linear regression. And we'll use a range. It's important to know that the range only accepts integers, but these both are integers, so we're okay. Now to get the y values, which we'll call y linear regression, we're going to use the predict function and plug in all of the x values. Lastly, we can plot the line by using plt.plot. We want the x values to be the x linear regression values, y to be the y linear regression values, and let's change this to be a red line. Looks like I misspelled something again. Let's fix that. And there we go. We created a model and plotted our line of best fit using linear regression.